Okay, we're going to start a new series focused on content. One thing with the MCAT that I think needs more support is where people get their content, how it is presented, and the fact that it takes so long to get through. So, in this new series, I've been doing some practice passages, but I don't think those are that helpful. So, instead, I'm going to put my energy into working on content. Now, I usually recommend people to go to Khan Academy and check out the Khan Academy videos. Like I said, it takes forever. So this is going to be a quick and dirty series of content based on Khan Academy. Okay, I'm just going to be going through the Khan Academy videos on my own, taking notes of the most important parts, and I'm going to basically be telling you what you need to know, what you don't need to know, in a summary. Okay, I've been tutoring for over a year now. I'm a 90th percentile MCAT score. So if you need any credentials, that's where I'm at. Okay, so welcome to the channel. We're going to get this series kickstarted. We're going to introduce as many videos as possible in these next few months. It's going to take a while if you plan on following along with the content. It is going to take time. If you're doing the content full time on your own, it usually takes about a month to a month and a half on Khan Academy. So I'm doing this kind of just in my free time here while I work. So if you're planning on following along while you're actually studying, I'd say don't wait on these videos. Just do it on your own time. Okay, but first off, we're going to start with amino acids and proteins. Okay, so first off, what is an amino acid? Amino acid is what we are seeing here in this picture. Okay, amino acids are the building blocks for proteins. All of them have very similar structure and different structure at the same time. Okay, every single amino acid has the same backbone. There's an amino group, a carboxyl group, and then there is a side chain. That's what makes them all different. They all have different side chains. Okay, so for the MCAT, no book is going to tell you this. Khan Academy is not going to tell you this. AMC is not going to tell you this. We need to memorize every single amino acid, the naturally occurring ones, their side chains, their three-letter denominations, their single-letter denominations, and a lot more stuff. But we'll get into that. Okay, so that's what amino acid is. We need to know that. We also need to know what peptide bonds are. I said amino acids are the building blocks for protein. So what the heck is a protein? A protein is just multiple amino acids linked together. Okay, so if we have amino acid 1 and amino acid 2, 1 and 2, they're going to form this protein made up of those amino acids. Okay, and we call that bond that links them together a peptide bond or a peptide linkage as labeled in this image. Okay, so a couple things I want to highlight here. First off is what type of reaction brings them together. This is called a condensation reaction. Okay, condensation reaction is a reaction that if you have like A plus B in the reactants, it combines them together to create AB. Okay, which is exactly what we're seeing here. We're seeing two amino acids to create one peptide. You could also say like A plus B turns into C. You could say it like that, okay? This is a condensation reaction. I know it's a condensation reaction because, just like condensation, water is a product. Okay, water is coming out. Okay, so two things that make me know it's a condensation reaction. There are things being combined, and water is a byproduct. Okay, and that's how a peptide bond is created. That's how amino acids are linked together. Okay, they're linked together to eventually create a very long chain of them to create a peptide. Okay. I also want to note, it doesn't show it, we also need to know the reverse of this. The reverse of this is just the exact opposite of the reaction. Okay, so condensation has an H2O going out. In order to break them, to cleave them, we put H2O in, and this reaction is called hydrolysis. Okay, if we break up the words, lysis means to break, hydro means water. Breaking with water is literally what it translates to. Okay, and we perform hydrolysis with a specific enzyme called a hydrolase. We need to know this. Questions on the MCAT will refer to these things: hydrolysis, hydrolase, and we need to know that peptide bonds are broken via hydrolysis. Okay. Water is used to cleave those bonds. Let's move on. Page 2. Okay. Whoops. Still getting used to this. New app here, so sorry about that. Anyways, these are all of our amino acids that we need to memorize. I recommend, if you're going to search for a picture online, to use the one that I have here, because there are a lot of different ones that organize them into various groups. I think this is the best place to start at. Okay, we have the non-polar side chains, polar side chains, electrically charged side chains, and basic side chains. Okay, just keep it easy like that. There are unique properties. We'll talk about what some of those are. Just to help get it organized better when you practice it. Okay. I mentioned earlier, we need to know the 3-letter denominations. We have them right underneath. Okay, so be aware of those. The single-letter denominations are in parentheses. We need to know all of those. Okay, for every single amino acid. One mnemonic I like to give out for the non-polar side chains. WF, or if you kind of say it out in a sentence, wife gave me lip. Just to remember the non-polar side chains, we have tryptophan, phenylalanine, glycine, alanine, valine. This little e means nothing, just a placeholder. Me for methionine, leucine, isoleucine, proline. Those are all of our non-polar amino acids. And I like to focus on that group just because it's the largest and it's going to take more time to memorize. And if you know that group, then it's a lot easier to know the other groups. Okay. The polar side chains are the ones with electronegative atoms, such as the oxygens, or the sulfur, or oxygens and nitrogens. Okay, so pay attention to those, and then it kind of makes memorizing polar versus nonpolar a lot easier. We also have our acidic and basic side chains, which are labeled as such. However, we also need to know that they would be considered polar for sure. So just be aware of that. Okay. So there's that mnemonic. I also want to talk about 2 other amino acids, specifically aspartate and glutamate. Can be very difficult to distinguish because they're so similar. They only differentiate. They're only different with 1 carbon. That's the only difference. Glutamate is 1 carbon longer. Okay, so what the heck does the single letter D and E have to do with anything when we're trying to memorize them? It's very difficult because there's no association, seemingly. However, with aspartic acid, there are 4 carbons. With glutamic acid, there's 5 carbons. Okay, D is the 4th letter in the alphabet. E is the 5th letter in the alphabet. So that's going to help distinguish between those. Now you'll never forget that. Write it down. I'm about to erase it. Pause, whatever you need to do. Okay, so that's another thing. We also need to know, let's see, 3-letter denomination, single letter, side chain properties, polarity we talked about, charge, acidic. These are all at a physiological pH, by the way. So at a physiological pH, acidic is going to be negative, and at physiological pH, basic is going to be positive. Okay. Stereochemistry. We need to know that every single one of them, all amino acids. Actually, let me change up the color here a little bit, just to make it a little better on the eyes. All amino acids Come on. Don't tell me this just died. Please. All amino acids are S configuration. S absolute configuration, except cysteine. Cysteine is R configuration. Okay, cysteine is the only one that's unique in that way. R, and I should say absolute, just to keep it consistent. Okay, and I'll tell you what absolute means, because there's absolute versus relative, but S and R are considered absolute configurations. All of them are S configuration, except for cysteine. Let me spell that wrong. Cysteine is R configuration because it has a sulfur in there, which throws off the priority of the groups. Okay, so all of them are S except for cysteine. Cysteine is R. So that's one unique property with the stereochemistry specifically. The other stereochemistry that we need to know is that all amino acids are, let's keep it consistent, are L relative configuration. All amino acids are L relative configuration. Cysteine is no exception. Cysteine is also L configuration. Okay, the only general exception is glycine. So in order to be considered S or R or L or D, you need to have chirality. You need to have a chiral center. Glycine is not chiral. So it cannot have any absolute configuration or relative configuration. Okay. So I said that I talk about what is absolute versus relative configuration. So L, you could be L or D, and that would be considered relative configurations. L and D shows you the stereochemistry of the entire molecule. And then S and R is our absolute figuration, which shows us the stereochemistry of a single chiral center. Okay, so kind of got a little off topic here, but just wanted to make sure we're touching on those bases. Let's finish this off with the last unique properties that we need to know for amino acids. So some other unique properties. There are some side chains which are ionizable. Okay. So ionizable side chains are all of the acidic, all of the basic, cysteine, and tyrosine. Those are all of our ionizable side chains. Okay, that seems kind of random right now. Like, what does ionizable mean? It's referring to the protonation state. Okay, But overall, I just want to go over what are amino acids, and what the heck do we need to know about them. These are the big things that we need to know about them. Okay, there might be a few things that are really, really small details here and there that you might pick up in questions, but this is the big stuff for sure. In the next video, we'll go over like more of the ionizable side chains, what that means with protonation, deprotonation, and then we'll get more into protein structure itself. Thank you.